Characteristics of normal distribution. The various particulars are given here: data elements, mean, standard deviation, variance, and number of elements. The notations for these particulars are given as parameters for population in the second column, and as sample statistics for the sample in the third column, and in the final column as sample mean statistics. These are all very important. These notations you can use either capital or small letter depending upon your requirement. Mu is the population mean. X bar is the sample mean. Here and here. Mu x bar is the mean of the sample distribution. This one. And then sigma is standard deviation of the population. S is the standard deviation of the sample, capital S. And sigma x bar is the standard deviation of sample mean distribution. This is here. And this is also called standard error. Sample size is small n. The types of distribution we will see. Uniform distribution, it is given by the function y is equal to 1 by b minus a, where x is greater than a and less than b. Otherwise, it is 0. The mean is given by the expression a plus b by 2. That is, if a is 1, b is 2, it is 3 by 2, 1.5 is the mean. And 1 by root of 12 is the standard deviation. And this is written and read as x is distributed uniformly between a and b, between 1 and 2, when I say a is equal to 1 and b is equal to 2. Bernoulli distribution. This is given by the function 1 cx. This is a combination formula. P power x, 1 minus p to the power of 1 minus x. And the mean is given by the proportion of success in each event, that is p. And standard deviation is given by the square root of the product of p and q. It is read as x is distributed as Bernoulli distribution with number of events 1 and proportion of success p. Binomial distribution is same as Bernoulli distribution, but instead of only one event, n number of events. The events have occurred n times. It is given as x, n, p, 0. That is, 0 is for the mean is 0 in this case. NCX, p power x, 1 minus p power n minus x, where n is the number of events, number of occurrences. The mean is given by n into p, and standard deviation is given by square root of the product of n, p and q. It is read as x is distributed as binomial distribution with number of events n and proportion of success p. Exponential distribution is given by the function y is equal to lambda e power minus lambda x, where x is always greater than or equal to 0. And if it is less than 0, it is 0. And the mean is given by 1 by lambda, and standard deviation also is given by 1 by lambda. X is distributed exponentially with the constant lambda. Poisson distribution, Poisson x lambda 0, it is written in Excel if you want to have any result. And e power minus lambda, lambda power x by factorial x is the function. And the mean is lambda, and the standard deviation is square root of lambda. And it is written and read as x is distributed as Poisson distribution with mean lambda. Gaussian distribution, which is normal distribution, the function is given as y is equal to 1 by square root of 2 pi sigma squared e power x minus mu whole squared divided by 2 sigma squared. The mean is sigma of all the values divided by number of values, and the standard deviation is given by square root of sigma of all the x values, x minus xi whole squared divided by n minus 1, and it is written and read as x is distributed normally with mean mu and standard deviation sigma. We will see a case study 1. A box contains 100 balls of different colors. Now ball color is given here: blue, green, red, orange and black. Number of balls with blue color is 20. Number of balls with green color is 20. Similarly, for all the colors it is given here. This I am going to plot in a graph. The colors are here. The bars are given the same colors. And if I plot it, it is like this. Please note the height is same for all because it is 20 by 100, 0.2 for all the colors. And this is called uniform distribution. Now we'll see Bernoulli distribution. Case study 2. Tossing a coin. So head or tail it will fall. What is the probability of head falling? 0.5. What is the probability of tail falling? It is 0.5. Total is 1. P plus Q is 1. So you can see here P plus Q is 1 and P is 0.5 and Q is also 0.5. 1 minus P. And the distribution is like this. Right? This is called Bernoulli distribution. If you have P is equal to 0.6, then head will be a little higher, 0.6, and this will be 0.4. Now we will see binomial distribution. I'm tossing a coin 2 times. When I toss the coin 2 times, total number of events are shown here. It can fall head on both occasions, or it can fall head on one occasion and tail on one occasion. That is shown by this orange cells. And it can fall as tail on both occasions. Now the probability of occurrence is given by this binomial expressions P plus Q whole squared, that is P squared plus 2PQ plus Q squared. What have we assumed? P is equal to 0.5. So what is P squared? It is 0.25. So 1 by 4. So the probability of 2 heads falling is 1 by 4, 0.25. Similarly, Q square is 1 by 4. Probability of 2 tails falling is 1 by 4. And 2 events out of 4 events can occur with 1 head and 1 tail. That is 2 by 4. That is 1 by 2. That is 2PQ is 1 by 2 into 1 by 2 is 1 by 4. 2 by 4 is 1 by 2, 0.5. Okay. Now, case study 4. Tossing a coin 3 times, it will be like this. And I'm going to use the same binomial expansion, P plus Q whole cube. So PQ, the probability of 3 heads falling is PQ, 0.5 into 0.5 into 0.5, that is 0.1 by 8, 0.125. Similarly, the probability of 3 tails falling is 1 by 8. And the probability of either 2 heads and a tail or 2 tails and a head is 3 by 8. Okay, this is 2 tails and a head, and this is 2 heads and a tail. Only these are all the events possible. A small business receives on an average 12 customers per day. What is the probability that the business will receive exactly 8 customers in one day? See, the average is given. We are given probability for a particular event. So mu is equal to 12, x is equal to 8 here. Now we are going to use this equation, Poisson distribution equation. Probability of capital X is equal to 8 is equal to mu power x. Mu is 12, e power minus 12 divided by factorial 8. If you substitute, you will get 6.55%. This is Poisson distribution. And the distribution will be like this. And the value is shown here in the plot. Now we will see exponential distribution. Gun tube failures occur according to log normal distributions, where the distributions are with high values. We can use log, and it is log mean is given as 7, and log standard deviation is given as 2. The log of the standard deviation is 2. Find the reliability for 200 round mission. What is the reliability? Whether 200 rounds will be firing. What is the mean time to failure and standard deviation? Calculations are like normal distribution only, but with log values. And this is a histogram plot for this. And we are using just like normal distribution. Transform log x 200 to z score. Logarithm of 200 is equal to 5.3. And at 200 rounds, z is equal to logarithm of t minus mu prime divided by sigma prime. This is nothing but log mean and log standard deviation. We have converted the x value to log values, and it is minus 0.85. Lifetime events. In lifetime events, either you can pass or fail, or you will select or reject. And one tail or two tail events can be numbered. Right? Suppose you toss a coin, you can say either get a tail, and then second time you also get a tail. Then these events can be numbered. You will have to number, and then only you can analyze. Events should be numbered. Event numbers already exist in the case of marks scored, because 50 marks, 60 marks, already numbers are there. So we don't have to put separate numbers for that. Event of selection or numbered 1, event of rejection or numbered 0. This is a convention. So you can use it other way also, but nobody would follow that. So success means 1, failure means 0. Yes, events are numbered as 1, no events are numbered 0. We will see central limit theorem. The final exam scores of an institute has a mean score of 74 and a standard deviation of 6.8. The exam scores follow a normal distribution. If a student is selected at random, what is the probability that his score is less than 65? Second question is, what is the probability that his score is more than 75? If a sample of 50 students is selected at random, what is the probability that the mean exam score of this group is greater than 75? Please note, in these two cases, we are going to refer to sample distribution. In this case, mean exam score is wanted. We are going to take sample mean distribution. What is the distribution for the mean exam score of 50 students? That means, what is the distribution that you are referring to in answering this problem? Find the 80 percentile for the mean exam score of the 50 students. And finally, find the IQ or interquartile range for the mean exam score of the 50 students. We will see one by one. Mu is equal to 74 is given, sigma is equal to 6.8, and the student taken is 1. Only sample size is 1 now here. If a student is selected at random, what is the probability that his score is less than 65? So what you need to do is, we have to convert the score of 65 to Z score. And the formula is x minus mu by sigma. So probability of x less than 65 is equal to probability of Z less than x minus mu by sigma. X I am going to put 65, mean is known 74, sigma is 6.8. Therefore, P is probability such that Z is less than minus 1.32. You can refer the table, you will get 9.34%. Right. This is the answer. Right. Okay, 74 is here, 65 is here, 65 is here, 74 is here. Now, you can use this formula in the Excel. You type this, you will get the answer. Z you have to put minus 1.32, you will get the answer in Excel. Any Excel you can take. What is the probability that his score is more than 75? Same way, probability that x is greater than 75 is probability that Z is greater than, substitute x is equal to 75 here. So probability that Z is greater than 0.147. So all you need to do is Z on the right hand side you have to take the area to the right. So that is 44.1%. You can refer the table or you can use the formula. This is the formula you can use in Excel. Z is equal to 0.147 you have to put. Okay. And find the area using Excel. We can use it. So Z test and cumulative distribution value, P value is 9.34. Okay. 0.147, it is 0.441. So from this you can refer. And then third question, if a sample of 50 students is selected at random, what is the probability that the mean exam score of this group is greater than 75? So here the standard error is to be used, sigma by square root of n. N is 50. Therefore, mu x bar is 74 and sigma x bar is sigma by root n we have to use. So probability of x bar greater than 75 is substitute 1 minus probability of x bar less than 75. Both are same. That means total together is 1. Probability of x bar greater than 75 plus probability of x bar less than 75 is equal to 1. Therefore, we are calculating probability of x bar greater than 75 using this relation. And that is 1 minus probability of Z less than this value. 6.8 by root of 50 is sigma x bar. That is standard error. Standard deviation for the sample mean distribution. And that is equal to 1 minus P probability that Z is less than 1.04, that is 14.92. You can refer this table here. Okay. This is the area for sample mean distribution. And what is the distribution for the mean exam score of 50 students? We have already seen this. Sigma x bar is the standard deviation for the sample mean. And therefore, x is distributed normally with mean 74 and standard deviation 0.9617. 6.8 by root of 50 is 0.961.